Okay, let's have another lecture, again based on my course at Aalto University. We'll see a bit of what can be done with molding and casting, so this is probably the shortest lecture. So just an idea of what you actually can do with molds and the casting, and a few ideas and few suggestions for designing them. So first let's see what are molds and how they work and what can be done. So of course this is just a very short introduction of all the possibility of working with molds, because in any case we need to work with technologies that are much accessible and easier, and therefore maybe not as high-tech or advanced as the traditional molding like injection molding and so on. So I will just show you this video. This is quite long, but it's very interesting because basically this is blow molding, so some sort of injection molding but with air. But that's something that was done in the workshops. So at least with this you understand also what can be done, and that's something that is just working really with a very simple technology and so on. So basically the idea is that you push some thermoplastic or something that can be transformed as liquid and then can be solidified later into one shape, 3D shape. There can be very different materials, and then basically the liquid fill all the shape and take that shape as the final shape. And then depending on the technology, there are different ways of having the shape and so on. So in this specific case, it's blow molding in the sense that basically it's using air to make that all the plastic goes and touch all the structure of the mold. So you have something that's empty inside. So that's how you do PET bottles. Okay. So you have the plastic and then the air, and then of course then the plastic is pushed against all the sides of the mold. In this case, you see, it doesn't have to be very complicated. So they're using the pellets of the plastic. I don't know which one, but as you see, with just boiling water, it's melting. So it's very low at this point. So it's probably polyethylene, not polypropylene. It's polyethylene for sure stands boiling water. Otherwise, you wouldn't cook pasta and okay, so that's the mold. This is very simple, but of course, in other cases, it will be this kind of injection mold, and of course, can be very complex. then you see the pipes. The pipes are for compressed air. So you just put in the plastic manually a bit just in place, and then inside the mold, and then it will basically hit the air, and then it will basically follow the plastic from the inside until it touches the wood. That's not the typical thing that we are going to do here, but just for an example, actually you could have different types, and that could be an idea for the next workshop. Okay. So, of course, the idea of molds is very big, so I will just show you a few things that are useful for us, just to make it shorter. So the first example is that these things are used not just in industry, but also by independent or DIY businesses. So for example, this is very interesting. There are two examples of additional toys for Lego that are done independently, just by using the specification of the Lego, and everything is done with injection mold. Okay, so in this case, if you buy Lego toys, you won't find as many weapons as you would like, probably, because of course Lego want to have liquefaction outside. So there is this company that basically is creating all the different weapons that you will need for playing World War II or other things. So you see, of course, you can have very different and very complicated and then refined shapes. And that's the mold that they will use. Okay, so it's two-side mold. We will see later that there could be even a one-side mold. The plastic is injected here, and then at the same time, it basically prints 4 objects. Then basically when it takes out, you need to remove that part. I don't know how it's called in English. In Italian, it's a very funny name, it's materozzo. The university, they told me materozze. Materozze. So that's also the size if you see here. The thing is also is you see here from the surface, this has been CNC milled. Okay. And that's also why traditionally this kind of molds are very expensive, because you need to be very precise and you need to mill it from aluminum or other things, other metals. and it takes a lot of time, and you need very powerful milling machines. Okay. But that's the idea, okay? Then of course this material can stand a lot of pressure and time, so this is the material you would like to use if you want to print thousands of objects. Of course, now we are not doing this, but we are just using more accessible material for doing some kinds of objects if you like. So for example, you can have very custom characters. These. That's something that you usually wouldn't be part of Lego. There is another company called Brickforge. They're not doing just weapons, but many other components that are not part of Lego. And again, they are doing with injection molding. So for example, you have the Vespa. You have guitars. So there is a very interesting interview about the guys that created this. So it explains a bit more about the whole process. And they're basically using the same approach of Lego. Okay, so they're using ABS. The precision is 1/10 of a millimeter. So if you really want a piece to stick together, so they're using the dimension, the process as well of Lego. So it's not that difficult that you really need a very big company, but that's for more advanced and professional results. The interesting thing is that, of course, that with the same structure you can do different things. So for example, this structure could be like a pool in the street or something else, just by changing the color. Okay, so that's interesting because also for the resin that we're using here, you can pour color. Some specific resins have some specific colors. Of course, you need to plan in advance which one because you cannot have all the colors that are possible. And with just few drops, 1 drop or so, they will color it. Okay, and that's interesting because according to what you're doing, you can reuse the same molds for different purposes. Okay, so even for the rain and so on. So the interesting thing, and of course, you can also use this for creating more advanced stuff. So for example, this might be interesting for you, your religion. So this actually, there are few fake trailers done on the web, like trailers that were remade with Lego. So that's interesting because it's on the Machete movie, which actually started from a fake trailer in a Rodriguez Tarantino movie. And it's actually absolutely the same, everything is done with Lego. So it's interesting because you see that you can actually do this kind of things with very...
They called him Machete.
$70 a day for the yard work. 100 for roofing.
Get in.
125 for septic. Signage.
Have you ever killed anyone before? As you may know, illegal aliens such as yourself are being forced out of our country at an alarming rate for the good of both our people. Our new senator must die, and for that I will pay you $150,000. Cash.
He was given an offer he couldn't refuse.
I cost the most. Because I'm the best there is.
Set up, double-crossed, and left for dead.
I took a vow of peace, and now you want me to help you kill all these men?
Yes, bro. I mean, Padre.
See what I can do.
He knows the score.
Where are my wife and daughter?
He gets the women. And he kills the bad guys.
Oh, shit. You knew that a Mexican day laborer is a goddamn federale!
But they soon realize
Coming after us.
they just fucked with the wrong Mexican. Action. Suspense. Emotion.
Please, Father, have mercy. God has mercy. I don't.
If you're gonna hire Machete to kill the bad You better make damn sure the bad guy isn't you. Machete. Rated X.
So the idea was taken from fake a character in a movie, then more, and there are even more movies now. But there is, for example, even on Flickr, there is a whole pool of people uploading pictures taken from recreation of movies with Lego or other stuff. So again, if you want to create custom things, so even if it's just for media, then you can also, with multi casting, you can get the same results. Okay. And there are many software for doing this. So for example, even on Linux, there is a software for doing stop and motion movies. So that's pretty accessible and easy to do. Okay, so let's see something about the mold design. The first thing to take in consideration that it could be designed with one side or two sides. And that depends if you want to have an object that is flat on one side or is like 360-degree round. In the sense that if you need to have it flat on one side, you could just have one mold, one side mold. If you pour it, then of course on the top it will be flat. And that's easier. Then if you want to have an object that is 360-degree side, then what you need to do is have two sides, and then you put them together and vertically you pour the material inside. That's a bit more difficult, but it's not that much. Okay. And then of course you need to understand on the sheet you want to work with and understand the positive and negative. And you need to understand also the material that you want to work with. If it's a hard resin or if you want to have something that's more as a silicone, software as a silicone. Because traditionally the process is milled from machinable wax that has a very fine detail. The counter mold, then we pour silicone or urethane, we get the mold, and then from it we cast the final resin or the chocolate if you use food safe. But if you want to have the object in silicone, you don't need a silicone mold, you can just cast it in the wax. So you need to design in a different way because the final object is already the first mold that you get out. Okay. So there are many materials. The easiest thing that also the most common thing in Fab Labs and we use is our material from SmoothOn, which is one of the main manufacturers. That you go on a website and you look for all the different kind of materials that they have because they have a very broad range of materials. And you download the technical bulletin because this has all the information that you need to understand how to work with the material. You need to learn, it's the same sheet that you will find in the package if you buy it. You need it because you need to understand how to mix the two components because usually there are two components that then when you mix together they have the reaction. You need to understand the cure time, so if it takes 24 hours or if it takes 2 hours. Yeah, if you need to understand the hardness, the tensile strain, the mechanical materials of the component, there's something over there, and so on. If you want to create molds for working with food, you need to be very sure that it's food safe. So some of them are food safe, so you can use it for working with chocolate or other things. I will show you one example with that. Well, this is for the one. So, okay, see this example of I did in the Fab Academy. So this is one side mold. This is for one Escher lizard. Okay. So that's the final result. So it's flat, so you don't care that it's just one side. Okay. The important thing here is that well, here there is one big problem. It's a bubble of air. Okay, so when I put the chocolate is not very liquid, so there was a bubble of air trapped over there, so there is a hole here. That's something that will definitely happen unless you use some vacuum chamber, which is a bit more expensive unless you build one. So in all the Fab Labs I've been, I've never seen it. I've seen only in very advanced prototyping facilities. So the trick here that you need to pour the material very carefully, very slowly from the bottom, and then you have to heat a bit the mold, so all the bubbles will evaporate. And then you really need to pray about that it's going to work. Otherwise, you need to redo it again. But ideally, that's something that works very well. And if you see here these lines are the trace of the path of the milling bit. So that's really precise. The quality of the mold that you mill, the counter mold that you mill, it's really taken into 1-to-1 ratio to the final object. So in this case, it wasn't milled with a very high precision. Also, the milling bit was quite big, so you still see the path. Okay, I will show you the Academy pages. But the result is quite good in any case for something done in like a couple of days. So that's the idea. I designed the mold in this way, like in 3D. Taking into account the block of wax that we have with the measurements, I designed it. And that's, for example, there's something like this is our two-side mold. Now, actually, this is not the silicon or urethane mold. Actually, I create basically Yoda. Okay. And in the end, I had time, I had more material, so I casted a transparent resin into that, so that you could see the difference of the two sides. So that's the idea, that you have a 3D shape inside that is divided into half by the two sides. So if you rotate it, you will see the different side, of course. Okay. So that's, of course, only with this final resin, not with the silicone. But that's the idea, that's for you to understand how to do it. So that's how you design it. Okay. So you really have to design the model you want to achieve, because that's what the CNC milling will be doing. So in this case, I divided the shape into half, and I had to be careful about the very fragile parts like the ears, because of course they need to be split into two sides, into the two molds. Then I added this small cone for making it easier to pour the resin. Okay, you need to have something like this for being sure about that. So that's the section. Okay, so this is just a cone. Okay, and that's the idea of the shape. So this is then when you get out, that's the final object. So ideally, you will need to have some rough angles. So this shouldn't be 90 degrees, but it should be, you have a very little angle. That's for making it easier to take away the mold from the counter mold. But if you're using silicone urethane, they're quite flexible, so it's not really important. But if you do this, that's something that you can do at the end when everything is ready. You just move the vertex here and here. That will help out. Even if you use a release agent, which usually is a spray, before casting the material, that will help out. So then you mill, and then of course that's the process for the MDX20, the traditional Tabla machine, but adapts to any milling machine. You first set at the Z. In this case, I used double-side tape and just glue, just to be sure. That was one of the first testing that I was doing. But if you use very strong double-side tape, it's enough. You don't need to use screws or other stuff. Just with this, it's okay. And then you mill it, and then of course that's the result that you will have with the machinable wax. So meanwhile you're milling, you should take away with the vacuum cleaner the wax, because you want to see if everything is going well. The other thing that you probably want to do, some labs do, they take away the milled wax with a separate vacuum cleaner. So then what happens, that if you need to redo it again, you can just melt it and do it again. So this is quite expensive material. It's wax plus polyethylene, so that's why it's called machinable wax. It's not normal wax. That means that it's tenth. There are different, of course, different grades of this material, but they're quite easy to work with the CNC milling machine. They don't melt, and they have a very nice finishing of the surface. So the idea that you want to reuse this. Okay. Then when you need to work with the silicones on the urethane, again, you have to mix the two components. Sometimes you mix by volume, sometimes you mix by weight. Sometimes you really need to put like, the ratio is 100 to 1. So if you put 100 grams of one component is really 1 grams of the other, so it's really like one drop. So that's why you really need a digital scale to be really precise. That's the ball, the sprite, the release agent. Usually these silicon urethane are quite dense, and when you stir them, then of course a lot of small bubbles will come inside. That's pretty normal. The problem is not where inside, the problem is where on the surface, but then you will have a hole. Then you just leave it for the hours they need for curing. One thing that somebody told me, yeah, you could try to leave the stick that you need for mixing the silicon on top of it, so then it's easier to take away. But some silicon actually, the curing is inhibited by wood. So what happened with this mold, that then this part in contact with the wood never actually cured, so it's always a bit sticky. So checking the instruction if there is something like this, otherwise just don't do this. But there's something you need to take into account, because if you use some specific material, then they don't work well together, so check on the instruction first. Okay, so that's it for this. I will show you, just to see a bit more on my Fab Academy exercise. So I basically download the shape from Thingiverse. Okay. Fixed it in Blender. Remove the doubles because of course it was not very clean. And then in Rhino, I use Rhino, but you can also use Blender, because in Rhino you're much more precise, but it doesn't matter that a lot, unless of course you need to use it for mechanical parts or something that you really need to be precise. So you just model it. Of course you need to leave some space on the sides, because you don't want the walls to be too thin. So for example, see here, if you leave very little material, then it can break down and then it's not very easy. So some students of mine, for example, they had this broken and they had to put a piece of wood on the side just to have that wall on side. So you can also do some bit of analog minor lacking later, but the idea you still need to leave some appropriate size of the walls. Okay, so this was done with the Royal modeler, the MDX20. So of course this is something that you can take out by hand. But of course the size of the millimeter was quite big. So for example here it didn't cut completely through, because it was too big for this detail. This is something again that it wasn't cut through, but you can take it away. As you see here, the path wasn't really optimized, so you still see the path here. But with a bit of luck and a bit of settings, we can improve this. So for example, when you have the, let's see, let's see here. Well, I will show you here. So basically, any cam for milling has different strategies for milling it, for milling 3D structures. So the easiest is parallel, so you just go parallel and you just follow the path. Okay. You could also do a cross, so you do it twice, or many more. The easiest is parallel. If you usually you will see just with this if it works and it's okay. If the software is really fine, then it's okay. Otherwise, you can just set it parallel, for example, rotating it by 90 degrees. So it will do it twice. So that's something a bit more that helps in the finishing. In this case, I wasn't really interested with this, so it's okay.
So it's possible to use a 3D printer.
Well, the idea here that we use the milling machine because it's much more precise. So you learn that with the milling machine is actually much more precise than that. Because here you see the path, but if you touch it, it's really smooth. If you do with the FDM 3D printer, you will have the layers. Yeah. Yeah. Like. So again, pouring it. So you see there are a lot of bubbles, but they are inside. I checked it. Few of them were on the surface, but they were very small, so in this case, it's okay. For these things, you can live with it. So again, then I put the chocolate. Of course, this is not very liquid, so it's not easy, so that's why there was the bubble here. So the problem of the bubble could be in the mold or could be on the final object. If it's in the mold, of course, you have to redo it. If it's in the final object, it's easier because the mold is already okay. Then let's see if I can show you something more. So actually before the Fab Academy, I did the Fab Bootcamp, which is the Fab Academy compressed in like 7 days in Barcelona. Let me see if I have some pictures. So if you see, this is the vinyl cutting. Okay. So that's the millet ball of the Yoda. That's an Arduino they did back then. No, I don't have more pictures. The other thing that I can show you in my final project in the Fab Money, they had one token, which is actually this. So the idea just to have one token that was, of course, each user of the lab has one. So you need something that is possible to duplicate quite easily. So you do the mold for this because then you cast it. And the resin for this just take like from 2 to 5 minutes to cure. So once you have that silicon, well, that's urethane mold, then in 3 minutes you have one. Okay. So I milled this. There were some problems with the MDX, so I actually had to modify it with the vertical drill, and you will see that it's not really precise because of that. Then with this, I did the. I can also show you the video. The urethane. Just need to use gloves for this. So you don't go all over the surface, you just pour it on the lowest part and then it goes automatically. It fills everything automatically. If you pour it like this, it's easier that you get bubbles inside.
Martino, ritorna a Boston. Yeah, thank you. Martino at Boston, so, Apple Fenico achievement.
For the bubbles to go. Yeah, in any case, you have to wait because you need to pour it. Okay?
I sent you
the
the
trick is the noise I have in the video. You pour it the machinable wand gently. Then if you eat it a lot, then all the bubbles will tend to move up. So that's the idea. Yeah, you have to vacuum chamber. Just an oven, and it takes away all the gas. Yeah, you can. You can.
Just did it like that.
I will show you one example.
You really want to shop it.
So that's the final thing. That's the resin, and that's the color. Oh, you see there are different tests. This resin, the Smooth Cast 325, cures very quickly. So actually, I was still stirring it. It basically cured in my glass. It's interesting that you see also the different results and so on. So that's the final option. What I did here, like all the tokens need to have a RFID tag, so I just dropped it, and it's part of it, so it's still hold by it. So you see here, these are the bubbles trapped inside, but it's not a problem in this case. Now let's see. one thing that I haven't had but I found lately, there is a lot of research on creating making soft robots. So robots that basically are structures that are made with silicons or are flexible resins, and basically by inflating it with air, they move in a different way. So this website is very good for this. So they have all the video for doing it. I will show you here. So this is one very good example. This is a prototype, a low scale, but the idea was for using an architectural scale. So that's something that when you inject air inside it, it moves. Okay, so that was the idea. So you have this structure, and then when it was milled, they mill it from aluminum or steel, but it didn't need to be that. So here you still see the path. So this is for the gasing it. Okay. They use a different color. Okay. So they created basically two sides. They glue them together, and then basically you see that by changing the way you put the hair inside, it moves in a different way. So it's a bit more advanced, but it would be very interesting to learn. And see, for example, again here.
The Soft Robotics Toolkit is a website that contains all of the information required to design, build, and operate soft robots. Soft robotics is a growing field which combines classical principles of robot design with the study of soft, flexible materials. Soft robots consist of low-cost, simple components that can achieve complex motions when inflated. For example, when we pressurize the air inside this actuator, it bends. Components like this can be mechanically programmed to achieve motions for specific applications, like this glove to assist with grasping tasks, or this cardiac simulator, which mimics the motion of the heart. The Soft Robotics Toolkit is a collection of resources to support users in developing these types of novel devices. Soft robots can be built by casting silicone rubbers in 3D printed molds. The toolkit contains mold CAD files that can be downloaded and modified. Users who want to design their own molds can follow the guidelines and step-by-step tutorials provided on the website. Case studies describing other people's designs can be used as inspiration. Once a mold has been designed, it can be printed with a 3D printer. The toolkit's detailed multimedia instructions explain the casting and fabrication process. The website lists all of the parts required for building soft robots, as well as links to suggested suppliers. Predicting the behavior of soft robotic devices is difficult. The toolkit contains tutorials and case studies on modeling and characterizing soft components to help users optimize their own designs. Much of the hardware used to operate soft robots is transferable between one device and another. So, the toolkit includes details of an open-source control board based on readily available parts that can be used for a wide variety of applications. The website also contains example source code to get users started with operating and controlling their soft robots. The board can be built as described on the website, or can be modified to suit the needs of particular projects. Soft robotics is a growing field, and the Soft Robotics Toolkit provides a way for students, designers, and researchers of all levels to learn how to design, model, build, and test their own soft robotics components, and to use these components to create novel devices for exciting applications.